All right, so when we're talking about page 2, as far as giving an example, any kind of example is good as long as you make sure you understand. So I can talk about angle A. When we're talking about equality, we want to make sure we're talking about the measure of angle A is equal to the measure of angle A. That reflexive property of equality is the one that talks about itself. My symmetric property of congruence, maybe I can say that segment AB is congruent to segment CD, therefore segment CD is going to be congruent to segment AB. It doesn't matter whether I list it left to right or right to left, it doesn't matter. All right, my transitive property of equality. Let's go ahead and we can say if A is equal to B and B is equal to C, then A is going to be equal to C. Again, remember that transitive property has that common link. We want to make sure that we can see that happening. And of course, our good friend, the distributive property, if I have a coefficient outside a variable, an algebraic expression, I want to make sure that we know that that's going to be 3x plus 6. I can distribute that factor to both of those elements there. All right, next comes finding the coordinates of the midpoint with a segment with those given endpoints. Yep, this is review, but you want to make sure that you know that the average of your x's and the average of your y's is going to be equal to your midpoint. All right, so pause the video, do some work, come back and check. All right, when we find that midpoint, we want to make sure that we find the average of our coordinate pairs. So for this one, I'm going to add 2 and negative 8 together, divide by 2. I'm going to add negative 4 and 6, divide by 2. For my next one, I'm going to add negative 1 and 2, divide by 2. Add 6 and negative 9, divide by 2. So those two midpoints we have. Make sure you understand with this one what to do if you're given the midpoint. So one of the harder ones are if you're given the midpoint and if you need to find an endpoint. Those are the ones that are a little trickier. So when you're setting up your x coordinate is equal to those values divided by 2, that x coordinate of your midpoint. You want to make sure the first thing you're going to do is always to multiply each side by 2, and then that gets rid of that denominator. So think about that if you're asked to find the midpoint if you are given, or if you're asked to find an endpoint if you're given the midpoint. All right, when I find the distance between 2 points is the difference between the x's squared plus the difference between the y's. So remember your distance formula comes from Pythagoras. So we're going to have the difference between my x's squared plus the difference between my y's squared. Take the square root of that whole value. So my distance of my first one in number 17 is 10 units. And the difference in my second one is going to be the square root of 37 units. That's a prime number, no common factors, no way for me to simplify it. So that'll do. So no, these ones are not. Therefore, they are not. Oh, that's coming down here. Okay, use the distance formula to figure out whether these ones are congruent. And no, they are not. Therefore, they are not congruent line segments. Here's the congruent symbol, not, because they don't have the same distance. All right, so for this one, we are asked to name linear pairs, vertical angles, and complementary angles. And I can kind of cheat sometimes when I talk about naming my angles. If I can, it makes it kind of easier. So linear pairs, 1 and 2 are a linear pair, 2 and 3 are a linear pair. I can't talk about this being linear pairs because 3 and 4 are not, 3 and 5 are not. So I have to go back to make sure I know how to name my angles. Angle ABC and angle CBE are linear pairs. CBD and DBF are linear pairs. All right, so vertical angles 1 and 3 are our easy ones. And again, I can't have 2 and this angle here because it's 4 plus 5. So I'm going to have to go ahead and name FBA and angle EBC are linear pair. And then my complementary angles are angles 3 and angle 4. When I add them together, ABC and CBD are going to be complementary angles. All right, let's check out the next side. So continuing on the back, I recreated the diagram. My supplementary angles in this case are going to be the same. If I wanted to think about trying to have, I know 1 and 3 are congruent, so can I have some other angles work as supplementary angles? It's not going to work out when they're all part of the same system. So for this case, they're just the same as the linear pairs. My opposite rays are going to be any place with this vertex B that creates a straight line. So BA, BE, BF, and BC. I was looking for one more, didn't happen. Adjacent angles, and this is where the numbering of the angles makes it super easy. So 1 and 2, 2 and 3, 3 and 4, 4 and 5, and 5 and 1. Any angles that share that common side can be adjacent. My congruent angles, we'll go ahead and have 1 and 3 are congruent because they're vertical angles. We can go ahead and say that EBD and ABD are congruent because they are both right angles. And you know what? There's one more. Let's talk about angle EBC, this big obtuse angle here, and this obtuse angle here. We can say that EBC is going to be congruent to angle FBA. All right, so for this next part, write the equation and solve for the missing variable. So the important part is that you know what equations to set up. So read carefully, come back and check your answers. All right, so we want to make sure you know how to set up each of these equations. These hash marks here are going to tell me that this distance here from A to B is going to be the same as this distance here from B to C. That's what it looks like geometrically. This is what it looks like algebraically, and then I can solve for x. All right, so when I have an angle, my seg or my angle addition postulate is going to tell me that this small angle plus this small angle is going to have the same measure when added together as this big angle. So I have the measure of each of these two little angles is equal to the measure of the big one. And I can set up that equation and solve for x. If I have vertical angles, then my angles are opposite of each other. So whether I have them in this left-right position or an up-down position, it doesn't matter. I can set them equal to each other, substitute in their expressions, and then solve for the variable. If my angles are a linear pair, they are both supplementary and adjacent, which means that they are going to add together their angle measures to equal 180, and then you can solve for that value. All right, let's check out the next video.